Okay, so here's another example, since we've done e to the 4x squared a lot. So here's this one. Looking at this one, is it a basic? No, nowhere near a basic. So what are my options? Is it an exponential? Clearly no. So I've got power and I've got ln. Why am I considering ln in power? Why?
There's no division rule.
There's no reverse quotient rule. So if I've got a denominator, either the derivative of the whole thing is in the top, in which case it's a ln, right? So if the derivative of the entire bottom is in the top, it's a ln. But if the derivative of if it's a power in the bottom, then it's going to be a power. So so which one do we think this is? A ln. So if we're thinking it's a ln, then we're going to look at this and say, what's the derivative of x squared minus 1? 2x. Actually, you know what? Let's do this one use substitution first, and then we'll come back. All right, so we think it's a ln. So if we think it's a ln, then we're going to set the denominator equal to u, right? Because in order to do a ln, we want just a basic ln would have just a single variable in the denominator. So what would du be? 2x dx. You need both pieces, because remember the d tells you what to do it with respect to. So we have all of this piece. Do we have all of these pieces? We've got the dx. We've got the x. Do we have the 2? No. Can we put it in? Sure. And take it out? Put it in, take it out? Oh, same thing. So now what do we have if we rewrite this? We've got that 1/2 out front. 2x dx. Does everyone agree that these are all in the numerator? 2x dx, that's exactly equal to du. And what's the denominator equal to? U. du over u. Is that a basic? Oh yes. That's the form that we need to recognize for ln. We could also write it this way. 1 over u du. That's another form for ln, but if we can see this, it's faster. We just don't have to rewrite it. So 1/2 ln u, absolute value. Did we start in u's? No. So we've got to go back. So 1/2 ln x squared minus 1. All right, so let's try it without u's. This one's kind of nice because it ends up du over u. That's sort of, for ln, sometimes that's a nice pattern, but let's see if we can do this without. Now erase. Yeah. All right, so let's look at this. If we go through the same process, is it a basic? No. It's got a denominator, so it's either a power or a ln. First thing you're going to check is, what is the derivative of the entire denominator? 2x. Is that in the numerator? Half yes, half no? Right, right. So it's got this part yes, the 2 no. So put the 2 in. Take it back out. Now, is the entire derivative of the denominator in the numerator? Yes, so that means we have a ln. So then we have 1/2 from the out front, ln of the denominator, plus it. So use substitution may be clearer in some cases. This method is faster, but you need to do whichever method gets you the right answer. That's the important part. So whichever way makes the most sense to you, that's the way you need to do it. And you're going to find as you do more of them that some of the steps you may need to write down less or skip writing down certain parts. That's fine. Don't skip in the beginning. Write everything out so that you can track what you're doing. Okay, let's do one more. Let's do. Do we want to do one more, or one more?
Sure.
Can we do a word problem? What's that?
I want to do that again.
The what?
The one that's after this one on the homework, or on the...
I did that. Oh, no, I guess we did do that one. Okay, yes, let's do that one. Excellent, thank you. All right, so let's do this last one. I'm going to, do you mind if I change it just ever?
It depends on how much you change.
What did I write, x squared?
Yes, x squared.
So I'm just putting it in the denominator instead, because that's all I'm doing is putting it in the denominator instead of the numerator. I promise you it's good. Am I right? I just put it in the denominator?
Mhm.
Okay. So let's look at this. Is it a basic? No. It's not an exponential. Is it a ln or a power? Is the derivative of, what is the derivative of the entire denominator? 5x squared minus 7 to the 4 times 2x, right, chain rule? Is that whole thing in the numerator? No. So that tells you that this is not a ln, it's in fact a power. So anytime we have that as a power, we want to rewrite it in power form. So integral of 3x, x squared minus 7 to the minus 5 dx. That's what we'd like to do. Still not a basic, but now it's clearer that it's a power, and we have an inside function. So our inside function is here. Derivative is 2x. Is that sitting beside it somewhere?
No.
Well, the important part. Remember, the variable part is the important part. The 2 is not there, so we got to mess with things. So let's do this. Let's pull that 3 out front because it's totally wrong. So just pull it out front, right? It carries through either way. X squared minus 7 to the minus 5, and now I'm going to put this x over here next to the dx, just because that's the form we tend to like. You guys seem to like it. It doesn't matter. Now, what would I prefer? What number would I prefer to have here? 2x. So I multiply it in, divide back out. Does everyone agree that multiplying it in and dividing back out, that's going to, we haven't fundamentally changed the problem. We've just rewritten it in a way that makes it easier to do. So now this piece is a complete derivative. So I know that it's antiderivative. This raise the power, right? So raise the power to the minus 4, divide by, plus all this other stuff going on out front, times the 3/2, plus the c at the end. So what goes in the middle? The middle. The middle stays the middle. Now we got to clean up. -3/8, I think. -3, yeah. So we get for our final answer, -3/8 x squared minus 7 to the minus 4 plus c. So I recommend that anytime the number is nowhere near what you're looking for, it could be a 4/5, it could be, you're looking for a 7 and you've got a 5. Anytime there's no easy way, I just pull it. This is like a permeable membrane, right? The 3 can go back and forth. Anybody likes biology, right? So the 3 can go either way, either direction. So I'm just going to pull the 3 out front and then do what I need to do. If I make any changes, I have to undo them so as not to fundamentally change the entirety of the problem. I've just rewritten it in a good way. Okay, let's do one word problem, and then I'm going to turn you guys loose to do some practice. So I'm looking at number 78. Number 78 on page 341. Okay, so it says you have a price-supply equation. The marginal price, what's marginal price? Do we remember that? That's going back to chapter 3. Marginal price? Marginal price is derivative. Marginal price we find it's how much the price increases. If I bump it up one item, it's how much the price increases based on the current projection. So it's a derivative. It's going up the tangent line. So the marginal price, given a supply of X bottles of laundry detergent, we are all interested in that, is given by this. So it gives you P prime of X equals 300 divided by 3x plus 25 quantity squared. Find the price-supply equation if the distributor is willing to supply 75 bottles a week at a price of $5. What does that last sentence mean? willing to supply 75 bottles a week at a price of $5.
For demand.
Yeah, it's kind of like saying the price at 75 bottles equals $5. Does that make sense? The price at 75 bottles is going to be $5. And why do I think to write it that way? Because I've got a P of X going on over here, so I think to write it in that form. And now I'm looking to find P of X. So how do I go from P prime to P? Antiderivative. So antiderivative. So yes, I'm going to rewrite it because it's this is going to be a power. Do we agree that's a power? So I am going to want to rewrite it. But since I'm doing the antiderivative, if you want to, go ahead and write in, right? That's what that symbol means. Go ahead and write it so that way you're not confused as to where you are in the problem. You were saying you need to find the antiderivative of that. So I've done two things at once. I've put what I'm doing, and I've rewritten into power form. So is this a basic? No. What is the derivative of the inside? 3. Do I have that?
Sort of.
Yeah, and then some. 3 and more. So there are a couple ways we can think about this. You can always pull that 300 through to the front. You can always do that. And then just start making things what you need it to be. And we'll do this one, use substitution as well, I think. So what do I prefer to have? Well, where do you want to have it? I guess over here. You prefer to have a 3 because that's the derivative you're looking for. So I'm going to multiply in the 3 and then divide it back out. Or you can say, I see the 300. The 3 is there. I'm just going to pull 100 out and leave the 3 because that's a part I need.
Negative 2 become a negative 1.
I haven't done the derivative, the antiderivative yet. See, so I'm just kind of getting it in the right form. So now, yes, now this is complete because I have the entirety of the derivative of the inside sitting right there. So I'm going to take the negative 2, raise it by 1 to negative 1, and then divide by. So divide by, yeah, all right, divide by negative 1. And then I've got 100 sitting out front. Go ahead and put the middle back in, plus C. Is that okay so far? Yes.
I put the 3 in front of the parentheses.
Here?
Yes.
That's fine.
When I went to divide it out, wouldn't I do 3 divided by negative 1? Or
If the 3 is here, that 3 is part of the derivative of the inside, so it gets sucked inside. So whether you put the 3 here, you put the 3 here, it doesn't matter, that gets pulled inside. Yeah, so that's why I like to identify the derivative. It's a little funnier when it's just a constant, because then it feels like maybe it should go somewhere else. But so it may be a good idea to write it back here with the dx, just to remind yourself that that's part of the inside derivative. All right, so what do we get to? So we got to P of x is equal to negative 100, and I'm going to write this to the negative 1. I'm going to put that back in the denominator, because we only really like it in this form when we're doing the calculus part, but when we actually start computing with it, it's so much easier if it doesn't have a negative exponent. So I'm going to write negative 100 over 3x plus 25 plus c. I need to find c. Do I have enough information? Yeah. So this says plug in 75 for x, because x is the number of bottles, and 5 for p, because p is the price, $5. So I'm going to have 5 for p, 3 times 75 down here. Oops, get that right. And then I just need to solve for c. So 100 over 250. So I'm not going to be able to do this in my head today. Somebody want to compute this? I think it's 3 times 75 is 225, 250, negative 0.4. Is that right? Anybody compute that?
Yeah.
Yeah. So I'm going to add 0.4 to both sides. So I'm going to get C is 5.4. So my final, is this my final answer? No, the final answer is what is the price demand equation? So it's up here, plug in the C. So my final answer is going to be P of X equals negative 100 divided by 3X plus 25 plus 5.4. That's my final price demand equation. It's just an antiderivative. Mess around with the constants. Plug it just like you've done a couple you did for the homework for those due today. Same thing. You have extra information, you can find C, and then you have your final answer. The last question it asks is, how many bottles would the supplier be willing to supply at a price of $5.15? So what am I asking there? How many bottles? What value am I trying to find? X, yeah. And what do I know? 515 is P. So I'm trying to find X for price equals 515. So we just plug in. So 515 equals negative 100, 3X plus 25 plus 5.4. Do we need to solve this one? Kind of like, I'm going to let you guys do that on your own, I think. So just remember, we're trying to get down to the x's in the denominator. So the first thing is we're going to subtract from both sides. You can invert both sides. I don't know if you guys know that. You can invert both sides or cross multiply, however you want to think about doing that. Okay, so I would really